Welcome to the GRACE project, where we are developing innovative technologies to reduce the carbon footprint of greenhouse vegetable production. I'm Project Director Brendan Higgins, and I invite you to join me as we explore these different technologies and learn how GRACE is reimagining controlled environment agriculture.
Access to fresh local produce on a year-round basis is appealing to many, and greenhouse agriculture allows this dream to become a reality. Because of this, controlled environment agriculture, such as greenhouse production, is expected to grow five-fold in the next decade. It promises access to local food on a year-round basis, but there's a catch. The current greenhouse infrastructure is a massive energy consumer, posing a challenge to achieving a low-carbon economy. Much of this energy is used for heating and cooling. With GRACE, we are using research, extension, and education to build a sustainable future for greenhouse agriculture. In this video, we will explore how our team of 18 investigators is set to revolutionize the way we produce food in greenhouses. Our team is focused on 7 technology areas that show great promise in making greenhouses more sustainable. Number 1, plant breeding. In this study, we're employing the age-old technique of plant breeding to develop crops with wider temperature resistance, specifically for tomatoes and lettuce. Most produce grown today has been bred to have desirable traits. Think bigger, tastier products. For example, lettuce originally was something akin to a dandelion weed, and over years of plant breeding, it's become the iceberg lettuce heads that we see in grocery stores today. Number 2, plant genetic modification, commonly known as GMOs, are almost indistinguishable from traditional plant breeding. Both technologies could have the same outcome, but by different methods. The main difference is that GMO plants contain precisely inserted genes or deletion of genes in order to achieve a desired outcome. GMO technology could be used to improve the temperature tolerance for tomatoes, which would lower the amount of heat required to grow tomatoes in the off-season and reduce the emissions associated with heating. Number 3, microorganisms play a crucial role in temperature resilience. By utilizing these tiny allies, we aim to enhance the health and temperature tolerance of tomatoes in greenhouses. Doing so would reduce the carbon emissions associated with heating greenhouses. Number 4, seasonal production. Instead of growing crops year-round, we're exploring the concept of seasonal production in greenhouses. This approach could limit produce availability in specific seasons, aligning more closely with Earth's natural cycles while reducing the need to heat the greenhouse. Number 5, bioenergy derived from plant waste material is our solution for sustainable heating and cooling of greenhouses. The existing approach to heating and cooling relies on the combustion of fossil fuels. We are evaluating if the energy left over from plant waste can be burned in place of fossil fuels to reduce the carbon footprint of greenhouses. Number 6, pathogen-free wastewater. We are researching ways to utilize treated wastewater for plant growth. This allows us to reduce our consumption of fresh water and reduce our use of chemical fertilizers that pollute the environment. Number 7, artificial intelligence, or AI, has taken the world by storm in recent years, and greenhouse production is no exception. By leveraging AI, we're optimizing greenhouse controls to achieve the most economic and production-efficient methods while reducing carbon emissions.
Thank you for joining us on this tour of these different technologies. In our project, we'll be evaluating how these different technologies impact greenhouse production. It is our aim to develop real solutions that benefit growers, consumers, and planet Earth.